Who is best? The Spider-Man or the Batman? The OSI model or the TCP IP model? Let's find out. Welcome to the comparison between TCP IP and OSI model. Welcome to iRush Academy, an unlimited learning platform to enhance your skills. Subscribe to the channel for more videos. Welcome to CCNA 200-301, Implementing and Administering Cisco Solution, Chapter number 18, OSI Model versus TCP IP Model. Learn CCNA with iRush Academy. The link to the complete playlist is available at the information bar at the right top corner of this video. So in this chapter, we will discuss about the similarities between the OSI model and TCP IP model. We will discuss about the differences between OSI model and TCP IP model. So let's talk about the similarities between the OSI model and TCP IP model. In the screen, we can see OSI model at left side of the screen and the TCP IP model at right side of the screen. The OSI model and TCP IP model are very much commonly using in the computer network field. They are the framework used to explain the computer network functionality, and they provide a standard approach to the computer networks. So let's discuss about the similarities between these two models. So the point number 1, layered structure. So in the concept of layered structure, what are the similarities between the OSI model and TCP IP model? So both models follow a layered architecture, dividing the network communication process into multiple layers. Each layer is responsible for specific functions and communication with the adjacent layer. So in the screen, you can see both OSI model and TCP IP model follow a layered architecture. They contain multiple layers. Maybe the number of layers are different in TCP IP model and OSI model, but both follow the layered approach. So in the OSI model, you can see there are 7 layers available. In TCP IP, there is only 4 layers available. Even number of layers are different. Their functionality is almost same. The OSI model provide more layers so they can deeply explain the functionality of the network parameters over the TCP IP model. Point number 1, the layered structure. So how the OSI model and TCP IP model are similar in the case of its layered structure? Let's discuss. So both models follow a layered architecture, dividing the network communication process into multiple layers. Each layer is responsible for a specific functions and communicate with adjacent layer. So in this screen, you can see the OSI model at the left side and TCP IP model at the right side. Both OSI model and TCP IP model are following a layered architecture. That means multiple layers. We can see here multiple layers. So this is one layer and this is another layer. In this way, the layered architecture followed by the OSI model and TCP IP model. And moreover, each layer is responsible for a specific function and it communicates with the adjacent layer. So as we can see, there are 7 layers in the OSI model and 4 layers in the TCP IP model. Even there is a difference in the number of layers, they both follow the layered structure. So in both models, each layer has a specific functionality. For example, what is the function of physical layer? The function of physical layer is to provide the physical connectivity to the computer network. And what is the function of data link layer? The function of data link layer is to manage the physical address of the network devices, and when it's go to network layer, its function is to manage the logical part of the networks. So in this way, each layer has its own functions and each layer is communicating with its adjacent layer. Here, if the network layer is communicating with the transport layer, and at the same time it is communicating with the data link layer. So the data cannot move from data link layer to directly to the transport layer without the involvement of a network layer. So network layer communicate with both the layer to make the network connectivity happen. So this is the similarities between OSI model and TCP IP model in the case of its layered structure. Now the point number 2, communication flow. Both models describe a bottom-up flow of communication. where the data is passed down through the layers on the sender side, transmitted over the network, and then passed up through the layer on the receiver side. Another similarity between OSI model and TCP IP model is the communication flow. How the communication flow in the computer networks. For example, when we consider a computer network, we can see here is one computer, its name is PC1, and here is another computer, it's called PC2. Okay, and we can consider a network switch here, and these two computers connected together. So now the PC1 is going to send some traffic to PC2. So how the communication flow is happening? So in both TCP IP and OSI model, the communication flow is happening in the same direction. In the sender side, it is starting from top to bottom, and at the receiver end, it is starting from bottom to top. For example, when the PC1 is going to send some traffic to PC2, the data will be flowing from top to bottom. So that means the data generated by the application, it will process by the application layer first, then it will go to the presentation layer, then it will go to the session layer, then transport layer, then network layer, then data link layer, and finally the physical layer. In this way, from top to bottom. When the PC2 receive the data, this will be the opposite way. That means from bottom to top. When PC2 receive the data, first of all, it will be processed by the physical layer. It convert the electrical signal to the binary. So it will go in this way, and from physical way to data link layer, then network, then transport, then session, presentation, and finally application. So at the receiver end, it is from bottom to up. So this is how the communication flow works in the TCP IP and OSI model. Now point number 3, abstraction. Both models use abstraction to simplify the complexity of network communication. Each layer provides a specific set of services to the layer above it, hiding the implementation details. We know that in TCP IP and OSI model, each layer has its own functionality. The total network flow is divided in between all these layers, and each layer working with the adjacent layers and helping in the network communication. So here we can see that each layer provides a specific set of service to the layer above it. For example, now let's talk about the physical layer. What is the function of physical layer? The main function of the physical layer is convert the electricity to the binary so that computer can understand. So what is a binary? Binary means zeros and ones. Computer is talking the language of zeros and ones only. So this binary data, the physical layer is transferring to the data link layer. So here, what service this physical layer provide to the data link layer? The physical layer provide the converted data from electricity to binary. So this is the data received by the data link layer. And data link layer, what is its functionality? Its function to manage the physical addressing. So it's look for the data and check the destination physical address. So the data link layer provide the physical addressing, that is the MAC address, to the next level. That means the network layer. So the network layer, its functionality is to provide the logical addressing, the IP addressing. So can the IP address work independently? No. It's need the MAC address along with that thing to recognize the device. So in this way, when we travel from one layer to another layer, we can see the previous layer provides some specific set of service to the layer above it to ease the network communication flow. Now point number 4, encapsulation. Encapsulation is a common concept in both models. In each layer, data from higher level is encapsulated with additional information. This is called headers or trailers, specific to that layer. This encapsulation allows for the proper functioning of each layer independently. So here, what is the encapsulation? The encapsulation is the process of adding some additional information into the data. This is in the form of headers or trailers. This helps the data to be delivered at the receive end without any error. So here, when we consider the data flowing from sender to receiver, the data flow will be from top to bottom. So just imagine the data is traveling from application layer to presentation layer, and from presentation layer to session layer. So here, there is nothing to control by a network engineer. The real function of network engineer is starting from the transport layer. So just imagine the data arrived at transport layer. So in the transport layer, there the transport protocol to be decided. whether it is TCP or UDP. So just imagine this is the data, okay, and this is going to send from top layer to bottom layer. So at the transport layer, we need to decide the protocol. So protocol, what protocol to be used, whether it is TCP or UDP. So whatever the result is, this information is encapsulating along with the data. So the data will contain what protocol it needs to be used, it's TCP or UDP. And in this transport layer, it also decide which port number it's need to use. Port number 80 or port number 443 or any other port depending on the service. And when the data then move from transport layer to network layer, in this layer, the additional information will be added from the perspective of a network layer. That means the IP address. So in the IP address field, what is the destination IP and what is the source IP? This information will be added along with the data. And when the data move from the network layer to data link layer, here the physical address will be added. So what is the source physical address? The MAC address, source MAC address, and what is the destination MAC address. So all this information will be added. And when this data going out of the physical layer in the form of electrical signal, all this information encapsulated from the multiple layer will be available with the data. And when it receive at the receiver end, each layer will look into this encapsulation data and act accordingly. For example, when it reach at network layer, the network layer will look what is the destination IP address and what is the source IP address. So from the source IP address, it can understand the data is coming from the source IP address. And from the destination IP address, it can understand that data need to send to which device. So this encapsulation is happening in both TCP and OSI model. And it helps very much in the communication between the source and destination through a network. Now point number 5, protocols and standards. Both models rely on the definition of protocols and standards to ensure interoperability and communication between different devices and systems. The protocols define the rules and convention for the communication at each layer. There are multiple protocols available in this world to rule the communication through a network. So in both OSI model and TCP IP model, the protocols define the rules and convention for communication at each layer. As we know, in TCP IP and OSI, each layer has its own functionality. In the same way, each layer has its own protocol, a set of protocol. These protocols are the one who decide the communication parameters, how the data need to be transferred and which port it need to be selected. So the protocols has very important role in the network communication in both the layer. Now point number 6, end-to-end communication. Both models facilitate end-to-end communication, meaning that data is transmitted from the source to the destination across the multiple layers, and each layer at the source corresponds to the equivalent layer at the destination. So basically saying the communication through OSI model and TCP IP model are end-to-end. When the source is sending the data to the destination, the traffic is moving from all the way from top to bottom. And when the destination receives the data from the source, the traffic is flowing in the opposite direction, means from bottom to top. And each layer at the source corresponds to the equivalent layer at the destination. For example, the network layer at the source side corresponds to the network layer at the receiving side. Data link also same, physical layer also same. So in this way, all the layer from the source, it is corresponds to the equivalent layer at the destination while receiving the data. Now point number 7. Modularity and flexibility. Both models promote modularity and flexibility. The layered architecture allows for easier modification or replacement of individual layer without affecting the entire system. So as we mentioned before, the OSI model and TCP IP model are following a layered architecture, and each layer has its own functionality. For example, the physical layer performs some specific function, and data link performs some other specific function. Network layer has its own function. So in this way, each layer has multiple functions. So in this way, the OSI model and TCP IP model promote the modularity and flexibility. For example, each layer performs some specific function, and only after that layer perform that function, then only the next layer can perform its own function. So each are interrelated. So if there is an issue at the network layer, we can easily work on the network layer and identify the issue by troubleshooting the network layer field without affecting the other layer. So here the problem is not affecting the entire system. We can work in a flexible way. For example, if the network layer is not working properly, then what will be the problem? The problem may be related to the IP addressing part, so you can check only the IP addressing part. Or what if the network port is not working? The network ports, the Ethernet is coming under the data link layer. So they can check easily what is the issue with the network port, and they can change the module if it is required. They can replace the cables in physical layer, etc. So each layer has its own functionality. They are individually manageable, they are flexible, and they promote the modularity. Now point number 8, concept of services. Both models define a set of services that each layer provide to the layer above it. For example, the transport layer in both models provide reliable or unreliable communication services to the layers above. This is the same situation in OSI model and TCP IP model. Each layer provides some specific set of service to the layers above it. Now all this time we were discussing about the similarities between the OSI model and the TCP IP model. Now let's talk about the differences between OSI model and TCP IP model. So what are the differences between the OSI model and TCP IP model? So the point number 1, in the number of layers. In the case of number of layers, the OSI model consists of 7 layers, namely the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. But on the other hand, the TCP IP model has 4 layers only. They are namely network access layer, internet layer, transport layer, and application layer. Now the point number 2, layer functions. So in OSI model, each layer has a specific set of functions, and in TCP IP model, the functions are more consolidated. So here you can see in OSI model, the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer, there are 7 layers. And in TCP IP model, there are only 4 layers. But when you compare both, you can see the network access layer from the TCP IP, it is divided into 2 layers in the OSI model, which is called the physical layer and data link layer. So in this way. So what are the functions doing this network access layer? It is divided in between these 2 layers in the OSI model. Functions are same, but in OSI model, it is divided into 2 layers to ease the network communication and to divide this specific set of functions. But in TCP IP model, still all those functions managed by a single layer. This is same happening with the application layer. The application layer has been divided into 3 layers in the OSI model. So whatever the single application layer doing in TCP IP, in OSI model, 3 layers are performing the same functions by dividing the functionality. So this is the one of the difference between the OSI model and TCP IP model in the perspective of layer functions. Now point number 3, adoption and implementation. While OSI model provide a comprehensive and theoretical framework, it is not as widely implemented in practice. The OSI model is more of a guideline for understanding networking concept. On the other hand, the TCP IP model is the model that has been widely adopted for the implementation of the internet. The TCP IP model's 4-layer closely align with the practical network protocol used on the internet. So basically saying the OSI model is not that much using in practical, but they are mainly using for the logical understanding of the networking concept. On the other hand, TCP IP is widely used and implemented in the practical network, especially in the computer network and internet. Now point number 4, development history. So the OSI model is developed by the International Organization for the Standardization, that is called the ISO, to provide a comprehensive and universally applicable model for network architecture. On the other hand, the TCP IP model is developed by the United States Department of Defense for its APRANET project, and it's become the foundation for the modern internet. Now the point number 5, layer Nomenclature. So in this case, in TCP/IP model, layers are named with generic terms like physical layer, data link layer, network layer, transport layer, etc. But on the other hand, in TCP/IP model, the layers are named based on the specific protocols they use, such as network access layer, internet layer, transport layer, and application layer. Now, the point number 6, usage. So, the OSI model is more of a theoretical framework and used for conceptual references. They don't use that much in the practical network, because in practical network TCP/IP is very popular and they are widely used over OSI model. So the OSI model is considering as a reference, it is considering as a theoretical framework to understand and learn the network. Now on the other hand, the TCP/IP model is a practical model and they are commonly used in the real world implementation, especially in the context of the internet. So TCP/IP are more popular in practical network than OSI model. So these are the differences between the OSI model and TCP/IP model. Now let's wrap up. So in this chapter, we have discussed about the similarities between the OSI model and TCP/IP model. And we have discussed about the differences between the OSI model and TCP/IP model. Thank you for watching. Please subscribe to the channel for more videos.